My dear students, in the previous video, we have completed the exercise 3.3. Almost all the problems in the exercise 3.3 are solved. Now, I am going to start the concept trigonometric equations. In this video, I am going to introduce trigonometric equations. Trigonometric equations means equations involving trigonometric functions. Trigonometric equations are equations involving trigonometric functions. For example, sin x plus tan 2x equal to 0, like that. This equation is called a trigonometric equation. We have to solve for x. Solving trigonometric equations, solution of trigonometric equations are the current exercise we are going to see now. This is an example. Cos x minus secant x equal to 2. Like that, trigonometric equations are expressed. We are solving these equations in this exercise. Before introducing the trigonometric equations, I am going to introduce a concept: closed interval, open interval, and semi-open, semi-closed, like that. Closed interval. Closed interval means, suppose in the number line 0, minus 1, 2, 3, like that. You consider 0, 1, 2, 3, like that, and minus 1, minus 2, etc. like that. If this is a number line, real line you have. Closed interval 1, 3. Closed interval 1, 3 means you have to express this interval by the bracket, square bracket 1, 3. Closed intervals are determined by the closed square brackets 1, 3. That means closed interval means this interval includes the endpoints 1 and 3. The endpoints are also included in the closed interval. That interval is called closed interval. Suppose open interval 1, 3. This is called open interval. Open interval is expressed by a simple bracket. Square bracket represents the closed interval. Simple bracket represents the open interval. Open interval means the endpoints are excluded. We are excluding the endpoints. Including endpoints are called closed interval. Excluding endpoints, like that. 1 and 3 endpoints are excluded. That interval is called open interval. Semi-open means semi-open, that is 5, infinity. This is called semi-open. From 5 is included in the interval, but infinity, up to infinity, the real numbers up to infinity are considered, or whatever it may be infinity, or number also we can take any number. The right side is open, it means right side number is excluding, left side number is including this interval. It is called a semi-open, and also semi-closed also. They are like semi-closed. Semi-closed. Here, right side 3 is included, left side minus infinity is excluded in the interval. It is called semi-closed or semi-open, like that. Closed interval means including endpoints. Open interval means it is excluded the endpoint. Semi-open, semi-closed are one side including, other side is excluding. It is called the endpoints included one side and other side is excluded. It is called semi-open. These two are semi-open and semi-closed. This is open interval, this is closed interval. See, using these ideas, we are going to solve the problems in the exercise trigonometric equations. So, you know that. Next, I explain what is a trigonometric equation and what is closed interval and what is open interval and what is semi-open and semi-closed. Like that, we studied about the intervals. And in the board, you have seen the trigonometric function and its domain and range. It was an important concept used for our trigonometric equations. Functions, trigonometric functions, its domain and what is the range of the function. Sin x is a function. Its domain is minus pi by 2 to plus pi by 2. Sin x domain values lies between minus 90 to plus 90 and range lies between minus 1 to plus 1. Similarly, cos x function. Cosine function range is domain is 0 to pi. 0 degree to pi 180 degree and the range is minus 1 comma 1 closed interval including endpoints. Tan x minus pi by 2 to plus pi by 2. Tan x function domain is minus pi by 2 to plus pi by 2 open. That means the endpoints are excluded except minus pi by 2 and plus pi by 2. All other values in between these lies have the domain of tan x. And range is open minus infinity to plus infinity, open interval. That is the range. Because why we should not including pi by 2 for in the tan x function is tan 90 you know infinity. So if you included pi by 2, tan pi by 2 is infinity, that means the function does not exist. The function is terminated. Therefore, tan x is an open interval of pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2. And range is minus infinity to plus infinity. Similarly, cot x. The domain 0 pi open interval and minus infinity to plus infinity. Range. Cosecant x, the reciprocal of sin x. Therefore, the range of sin x is same for cosecant also. But 0 is excluded except 0 degree because cosecant 1 by sin, if you included 0, 1 by 0, it leads to infinity. Therefore, in the domain excluding the 0 degree, in between minus pi by 2 plus pi by 2 open interval is closed interval is cosecant x. Domain of cosecant x is minus pi by 2 to plus pi by 2 except 0. Similarly, its range is in the real number system, open interval minus 1 to comma plus 1 number, in between minus 1 to plus 1 intervals, numbers are excluded in the real number system, except the open interval minus 1 comma 1 or the range for cosecant x. Finally, secant x is same as the cos x function, domain 0 to pi, but secant pi by 2 is infinity, therefore excluding except pi by 2, 0 to pi, excluding pi by 2 is the domain, and range is x in the real number system except minus 1 to plus 1 in values, except all the values except minus 1 to plus 1 in the real numbers are called range of secant x. In the range of secant x is in the real number system except minus 1 open interval numbers are called range. In the domain, pi by 2 is excluded because secant 90 is infinity. So, domain, the various trigonometric functions and its domain and the corresponding ranges are given. You remember these things for our chapter trigonometric equations. Now, what is the general solutions and the principal solution of a trigonometric function? Now we are going to see solutions of trigonometric functions. Solutions of trigonometric equations. First, principal solution. Principal solution. Principal solution of a trigonometric equation is the solutions lies between 0 to 2 pi, 0 degree to 360 degree. The solutions involving 0 to 2 pi, in between 0 to 2 pi are including 0 and excluding 360. This is semi-open, this is closed. Left side is closed and right side is open. That means 0 included, 2 pi is excluded. Less than 360, up to 259 and all, except the 360, all other degrees are included. Therefore, semi-closed 0 to 2 pi, in this interval, x lies in this interval 0 to 2 pi, semi-open. Values are the principal solution of the given function. Principal solution lies between 0 to 2 pi. General solutions, the x values, principal solutions are x values lies between 0 to 2 pi are called principal solutions. General solutions the general solution except these values lies in the values excluding the values except these principal values, all other values are called general solutions. The values x lies the number, the solution represented by a number n belongs to z. The various values of n belongs to z, set of integers, are called the solutions represented by a number n belongs to z are called the general solutions. For the values except the principal solution, all other values for n belongs to z, for various values of n belongs to z are called general solutions. Now we will see the exercise problems one by one. These are the principal solutions and general solutions for a trigonometric function. Now the exercise 3.4. You should remember that principal solutions are lies between the values 0 to 360 degree. On all other values except these principal values are called general values or general solutions. Before going that the general solutions for the trigonometric function, we have one tabular column for the results. Function, trigonometric function, and the general solutions. You should remember this results for solving the exercise problems. First, sin x equal to 0 is a trigonometric equation. Sin x equal to 0 is trigonometric equation to connect a function instead of writing that equation. Sin x equal to 0, general solution is x equal to n pi, where n belongs to z, set of integers. Second one, if cos x equal to 0, sin x equal to 0, then x equal to n pi. If cos x equal to 0, then the solution of the equation cos x equal to 0 is x equal to 2n plus 1 into pi by 2, where n belongs to z. 2x plus 1 into pi by 2. For various values of n, various general solutions we have. Then third one, tan x equal to 0 implies x equal to n pi, where n belongs to the Indian set. If sin x is 0, x equal to n pi. Cos x equal to 0, solution x equal to 2n plus 1 into pi by 2, where n belongs to z. In each and every case, the number n is in the set of integers. Tan x equal to 0, x equal to n pi. Fourth one, if sin x equal to sin y, where y is in the interval minus pi by 2 to plus pi by 2. If sin x equal to sin y is the equation given, y is in the interval minus pi by 2 to plus pi by 2, then the solution of x for this equation is x equal to n pi plus minus 1 power n into y. X equal to n pi plus minus 1 power n into y, where n belongs to the set that. Fifth one, if cos x equal to cos y, where y belongs to the interval 0 to pi cos x equation, then x equal to 2n pi plus or minus y, where n is in z. 2n pi plus or minus y. And these are the results you should remember. Using these 6 results only, you can able to solve the equations of trigonometric equations. Next, tan x equal to tan y. This y belongs to the open interval minus pi by 2 to plus pi by 2. X equal to, for this equation, x equal to n pi plus y, where n belongs to this. These 6 results are very important for solving the problems in the exercise. You should remember these results for solving the problems. Using these 6 results, now we are going to solve the problems in the exercise 3.4. Exercise 3.4. First problem, find the principal and general solutions of the equation tan x equal to root 3. Find the principal and general solution for this equation tan x equal to root 3. Both principal and general solution. You know, tan x equal to, what is the value of tan is root 3? Tan 60 is root 3. Therefore, this is tan 60. Tan 60 is root 3. Therefore, if tan x equal to tan y, our answer is principal solution pi by 3. X equal to pi by 3, and principal solutions are, you know that the principal solutions lies between 0 to 360. Therefore, principal solutions are pi by 3. Tan value is positive in the first quadrant and in the all silver tea, third quadrant. For all silver teacups, fourth quadrant also tan positive. So pi by 3 is in the first quadrant. In the third quadrant also tan value is positive. So root 3 in the third quadrant, tan value of root 3 in the third quadrant is 360 minus 60. 360 minus 60, that is 300. What is for, sorry, third quadrant. All silver tea cups. Tan positive in the third quadrant. Third quadrant, first quadrant 5 by 3. In the third quadrant also positive, that is 180 plus 60. 180 plus 60 is 240. That is 240 is 4 pi by 3. This is equal to 4 pi by 3. So principal solutions are pi by 3 and 4 pi by 3. These are the principal solutions. For this equation tan x equal to root 3, x equal to pi by 3 and 4 pi by 3 are the principal solutions. Then general solution is, you use the sixth result, tan x equal to tan y, general solution. If tan x equal to tan y, x equal to n pi plus y, y is the first value, pi by 3. N pi plus pi by 3, where n belongs to z. These are the general solutions, and these two are the principal solutions for this problem 1. So, in this video, I have given, I defined what is the open interval and what is the closed interval, definitions of closed open intervals. and also I gave the domain and range of various trigonometric functions, and I gave results for 6 trigonometric equations. Using these equations, we are going to solve the exercise problem 3.4. In this exercise, first problem only I have solved. What is the principal and general solutions of tan x equal to root 3? And I will stop here in this video. I will stop up to this. In the next video, we will continue to solve the problems in the exercise 3.4. Thank you.